Aloha, Richard Halverson here. This is ICS321, and today is June 30th, Wednesday, June 30th. Let's see, I'm actually going to be going up to visit my family and my wife's family in Minnesota tomorrow. So I just thought I'd mention that. So I may only schedule one class next week. And it'll probably be a morning, like this time of the morning, because it's 5 hours later there. Anyway, but I gotta go up there first to find out what my wife has planned for us. But anyway, so probably only one class next week. Let's see. Let me share my screen. And we are starting. Can you see my screen?
Yes.
Okay, I don't have that funny thing surrounding me. I'm recording, aren't I?
Yes.
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 So here we are. It's we are starting chapter 5 today. Last time I finished up chapter 4. And I might do a couple more of these Garden Glory SQL assignments today, statements today, maybe at the end. And there's a bunch more of them in Queen Anne. And the timing is right, because we just finished up sub queries and complex queries over here. We just finished that up. But anyway, today we're going to start with chapter 5. And so we're going to learn more about programming, about programming languages that are used along with SQL to, get work done. So programming languages, there are kind of the mathematicians have divided programming languages up into two categories. There are imperative languages and there are declarative languages. And imperative languages contain control flow statements, C, JavaScript, Python, PHP. Those are all imperative languages, and you have if statements and for loops and all that, and your program is a sequence of statements that are executed in order, and there's jumps and so on. Imperative or declarative languages don't have control flow statements. They just have a statement which declares what result is desired, and that's what SQL is. You'll notice these SQL statements. You just say, okay, I want this table derived from this other table, but I only want these parts. You figure out how to do it and just give me back the table. And so that's declarative. And I've often I noticed that some students that are really interested in becoming programmers, and they take computer science, and sometimes imperative languages are difficult for them. It's difficult for them to see the flow, but declarative languages are just fine. And so a lot of those students who still want to stay in programming find their home in SQL. And what's nice about SQL is, SQL is going to be SQL for as long as for our lifetimes, whereas imperative languages, they're coming up with a new imperative language every 10 years, and you got to learn something new, which isn't bad. Anyway, so make sure, or it's a good idea to understand the difference. In this course, you can't do everything with declarative, and so in this chapter we learn about how we mix imperative with SQL. And so here's an example of a declarative language and a procedural language. Select the airline name and the flight number from the flight table where the airport code is JFK and where it's departing after this time here. Instead, a procedural language would, I guess, first it would output the I guess it would output the title of the thing. This, just like in SQL, it prints out the it outputs the column names first, and then there'd be a loop, and it would look at each one, and if the airport code is JFK, that's what this tests for, and the departure time is after 12. That's what that tests for. Then print out the airline name and the flight number underneath these. Okay, so anyway, that's the difference. So the SQL compiler has got to probably produces this from this. But they're a lot smarter, you know, they know how to find shortcuts, but they know how to use the indexes for sorting and so on. All right, so let's make sure you understand that. Now there's 3 database programming techniques, and I think we might touch on a couple of them at least. 2. There's embedded SQL, where you embed SQL right in with another language, and I guess MySQL or the PHP is kind of like that, but and then there's procedural SQL, which extends the SQL language itself, and we're going to be doing this in assignments 6 and 7, procedural SQL, and that's where we write code that MySQL executes, and it's procedural. And then application program interfaces. Okay, this talks about I think this talks about the interface inside a programming language that interfaces to the SQL. Okay, and I think that's what they talk about. That's what they mean when they talk about application program interfaces. There's another. We also use the term application programmer interfaces for programs that we write on the that sit on the server that respond to JavaScript AJAX requests. Those are also called application programmer interfaces. You know, they reply with JSON, JavaScript objects sent back, and so on. And we're going to be doing both. Someplace explains that. Okay, so advantages and disadvantages. Embedded SQL allows a programmer to write SQL statements directly within another programming languages. This explains the pluses and minuses. Procedural languages vary significantly by database. We're going to learn one. We're going to learn MySQL's procedural language, but it can't. There's a lot it can't do. I mean, it really does expand the usefulness of SQL. Being able to put constraints in is just really valuable. Triggers, you know, keeping things from being inserted into the table, into a database table that you cannot enforce by some sort of field constraint. And then okay, so here API, what compile steps variable. Okay, so this is a good table to know because of the questions that come later. Anyway, okay, so so that's kind of the difference. Now, let's see what's. I'm not in this chapter anymore. I'm in this chapter. So let's go on. I guess we're going to talk about each of these in more detail. Okay, embedded SQL. SQL statements appear in programs written in another language. So it's like this. This is like C. This looks like C code. Okay, so this is a regular C program, but inside you have this embedded SQL. And so we sort of switch over to the SQL mode, and we throw some SQL in there, and then we are done. I'm not sure how, I'm not a C programmer, so I'm not quite sure how, I guess this is just an action that we want the SQL database to perform. So it doesn't need a response. Okay, so which is the correct embedded SQL? Some points are you have to have the semicolon, you have this execute SQL up here, and it's on a separate line, so that narrows it down to one of these two. And this one's got the semicolon, this one doesn't, so it's this one. And embedded SQL is commonly supported in C, and a pre-compiler translate embedded SQL into, I guess, the host line. This one, I'm not sure. I guess. Okay. All right. And so this talks about how you still need to have the connect up at the top to connect your program to the database first, and we have to do that in our assignment 6 and 7, our assignment 7. I'll talk a little bit about assignments, the rest of the assignments later today too, because it's a good time to do that, because we actually have assignments that involve all three of these kinds of programming in one way or another. So we're still in embedded SQL, and actually we aren't really going to do any embedded SQL like we see in C. So, but you want to go through this and do the participation exercises. Shared variables can appear in which clause of an embedded select statement? So shared variables appear in an into clause of a select statement. Okay, I see. So we select those variables and we store them into these shared variables here. Okay. Anyway, that's interesting. I'm sorry. I guess I don't have us experience any embedded SQL, not like this, but you should still understand it because you might have to someday. Procedural SQL. These are stored procedures, and they're they're coded beforehand. You write the code beforehand, and then you call them just like you would execute any other SQL statement. Okay. A procedural SQL is compiled in 2 steps, where a pre-compiler is followed by a compiler. Okay, that's actually embedded SQL, and if you don't see that up here, you had to have read the previous section to know that this is false. Stored procedure is compiled every time a procedure is called. Gosh, I don't think so, but maybe it is. I think this is false. Differ significantly. Do they really differ significantly? Does it say that? I bet it does say that, even though it probably doesn't really. Let's see.
Yes, it says significant.
Yeah.
Yeah.
I would say that's probably false. Yeah. Okay, so here it talks about how you create a stored procedure. This is interesting to know and to look at in our but phpMyAdmin helps us with all this. Okay, and so we just type stuff into the phpMyAdmin form, and then we can display the procedure, and we'll see that it comes out in this format. So that's stored procedures. And in fact, maybe now, see, so you can have loops in stored procedures. This is what an if statement looks like. I sometimes, well, they actually do have to use the word then, and then there's else and if and while. So that's, and so how far down does this go? Declares, there's several ways to declare variables in stored procedures, and I only, I learned that having separate specific declare statements, I began seeing the value of that later in my SQL programming experience, and because sometimes the SQL compiler gets mixed up if you use the same names in different forms and so on. So it helps to, this is standard, more standard. Cursors, that's so you can keep track of where you are in a table. So I'm not really familiar with the difference between stored procedures and stored functions. I presume it's just a matter of how they're called and how they're used. And stored functions can probably be called by stored procedures. And triggers, we're going to be making a trigger. Let me switch over to talk, and we can take a look at some of these with the assignments. And you can take a look at them now and see how far are we. I haven't posted assignment 7 yet. Somebody asked about that. The reason I haven't, assignment 7 has everything. And the reason I haven't posted it yet is because I've got code here. This is stored procedure code. And basically you just fill in some blanks. And this talks about how to do it and how to test it. I'll put this up like maybe even later today. What's not going to be here is I have this is PHP code to access your stored procedure. You're going to implement this stored procedure on your server, and this is PHP code that you just pop over there and fill in your username and password. And this executes and calls your add place stored procedure. I want to give you the choice of implementing this in either PHP or Python. So I wanted to post up the Python code first before I open up this, but I think what I'm going to do is because somebody's there already in the assignments. Very good. So I'll just post this up, and I'll get to the PHP probably in the next week or so. The Python probably in the next week or so. But anyway, so this is a PHP code that executes MySQL on the server. And so here we start out by connecting to the MySQL server on the local host and the username and password, and identifying the database that we want to access. And this is a select statement that we want to execute. And we store it in this variable here. In PHP, all variables begin with a $sign. And then you're going to add some code here. And it's probably there's a video for this somewhere. And then this actually executes. This finally executes this SQL statement. This code adds a where clause onto this SQL statement, is what you're supposed to do. And this comes back as a table, and I declare an array here, and I push the rows of the table. I push the rows, this is one row at a time, push rows of the table into this array, and then I return the array inside this JSON object. So anyway, and you'll see all that. You just get this to work, and probably, you can run it without putting your code here and you'll get everything back instead of only, you're supposed to be able to search for places. So your searching won't work, but you should get something back and you can see that. And then this is also some HTML that you're going to put on your server to connect to your code here. So this is your code it's going to run on the server, and this is HTML that's going to be well, that eventually ends up in the browser, the user's browser. It's a dumb form. It looks kind of like this. Looks like this over here. And here we just this is PHP that displays out this table here. So anyway, and then that's the last assignment. And the second to the last assignment, which is posted up there, here you create a database, and basically you're transforming this thing into 3 tables, and it has to be 3 because it's got to be in B. It's not in B anyway. BCNF. So this tells you how to create the table, and this tells you how to use select statements to insert. This shows you how to get back the original table. Anyway, then you're going to create a trigger, and what this trigger does is it keeps you from it's entering in. You're trying to enter a record into this table, and certain conditions have to apply before you can insert a record into this table. And the store procedure, the trigger tests to make sure those conditions are met. And if they're not met, it rejects the insert. So it accepts a campus and a place, and the trigger should first determine if, okay, place has to be in this other table first. If place is not in this other table, place has to be in this other table, and campus has to be in this other table. If neither of these are in the other table, then it rejects the insert. And then this is another trigger. Okay, so I guess we're only doing triggers with this assignment. And then the next assignment is a store procedure. All right, so anyway, and what's, and then, here, these are Queen Anne assignment 5 is a store procedure. No, yeah, here's a store procedure. So here's the store procedure, and there's some places where you need to insert some missing statements. And oh, look down here, I give you all, it's like a puzzle. I give you all of the missing code, and you have to figure out where up here these go, these things go. I bet you this one goes here. So anyway, so that's assignment 5, and then this is a real simple trigger that you test something has to be true. But the next assignment, which is this assignment 4, Queen Anne database, here you actually create the Queen Anne database, and what do I give you? I actually give you this is the whole database. Look, it's the create statements and the insert statements to create the database. And I think you may have to put in some sort of constraints or something. And again, you have your grading assistant here, but so for assignment 4, this tests the schema. Let's see. And so I did mine already. And then after that, there's more SQL statements. And so later on, I will help you with these. So anyway, it's the same kind of thing. Different table. All right, so let's go back to here. And we'll just talk a little bit more. I'll talk up to application programmers interface, and I'll save database programming with Python and database programming for the web. I'll save those for next week, and I will have put up the code, the Python code for assignment 7 and post assignment 7 by next week, so it'll be appropriate. All right, so so here it talks about creating a trigger, and we're actually gonna, I'll log in here. So let's see, there's the trigger over here, right? Procedures. Yeah, a bunch of procedures here. Okay, so I think there's a trigger in sale item, maybe. Sale. So here's a trigger. So for trigger, you click on triggers, and then you can add a trigger, and then you add it all in, and it looks like this. You put a name, and you say what the table is, and you say it's before. You do the trigger before you do the insert, because you want to keep a trigger from insert from happening. You may want to have something like where you're recording updates. Let's say you have something, and whenever there's a change, let's say it's something really important, and you want to record updates to a table. You want to record the old value and the new value, and then you would have an after insert trigger, and then insert afterwards. But anyway, so, and then this is where you type stuff in, and when you start out, it's blank. So you type a begin statement, and then you start typing in stuff. This is another way of doing variables. You just do this @ sign in front of it. And then so here, this is a select statement, which is going to return a single scalar value. And so that's stored in there. And then there's an if statement and so on. This thing makes sure that the primary key, or the key, is set correctly or something. I think that's what this does. So that's and when you export it, this is a nice output, create trigger. So this is how you'd this is kind of what the book talks about. For procedures, I don't know how many of these procedures you actually have to write, because I think these are over a few years using this assignment for or using this scenario for an assignment. This doesn't get any bigger. So this is a pretty big trigger. I mean, pretty big stored procedure, a bunch of inputs and a bunch of outputs. And so this is where you typed in, oh yes, look, this is the assignment. See, so here I've actually, these are the correct things inserted in. Okay, so this is the finished assignment. And of course, then let me close. And this is assignment, this is the QACS. So if we go back to here, it's this one. It is the procedure test. Let's see what this looks like. So I'm testing your add sales stored procedure here, and I insert, I insert some stuff, I test some stuff, and things have to pass, and in the end it says I got all the points. I think I insert a bunch of stuff and then I delete it all back out again to try to leave your data set the way it was before I graded it. So anyway, so that's how for this, with this exercise, you get to finish writing this stored procedure. All right, so triggers. Fill in the keywords to create a stored procedure that adds entries to the seat table. Okay, gee, I haven't done this one before. Well, let's try to plow our way through this. All right. A is create. Have you done this yet?
Sorry, not quite yet.
No? Okay, and that's right. Create trigger, create procedure, add seats. This must be this is either an in or an out. It must be an in. And C is how many must be an integer, maybe. And D might be this is a procedure, so let's go to procedure. In chart 3, begin. This has got to be begin. And then less than do. Is it a yes, the word do. Do. What's F? Set. Set, I bet. Sure, set. All right, let's see if this is right. Oh, well, there you go. Not that bad. All right, you can do the next one. Okay, what is this? What does it have to say about application programmer interfaces? Okay, an application programmer interface specifies the interaction between an application and a computer service. So if the application is written in C, the API specifies procedure calls. If the application is written in an object-oriented language, then it's API specifies classes. That makes sense. So these all help when you're in writing a program and you're writing a program on a host and you want to access the database. So PDO, no, we aren't using PDO, we're using something different, but PDO is one type of interface that you can, for PHP to interface to SQL. So, all right, here it says the use of the term application programmer interface varies. The term also refers to the syntax and expected behavior of procedure or class declarations. In some cases, the term also refers to the implementation of procedures or classes in incomplete code libraries. Okay, so this is kind of what I was talking about. So what we're writing in PHP and in Python are also called APIs in a lot of contexts. But in this particular one we're talking about right now, we're talking about, let me just go to assignment 7. we're talking about, where's the PHP? So here's some PHP here. This is PHP, and this is a PHP statement, but we're connecting to the MySQL server. Here we're connecting to the MySQL server. So in this context, we're talking about those kinds of APIs. All right, which API supports only one language? I don't know.
The database API.
This one? Yeah. So maybe that's what we're going to be using for Python. All right. Oh, this one must be. All right. So yeah, here we got the connection. This looks like Java. So here we have these connection statements. So this prepares the, yeah, this looks like, this kind of C# is kind of like this too. So this is kind of interesting. ODBC also does Excel and other kinds. All right, so I'll save this for later. So let me do, and got a little time left. Let me do some more of these assignment these here. Yesterday we got up to, we did these two. Let's, we can see what this one is. Write an SQL statement to list the last name, first name, and cell phone for all employees having an experience level of master and a first name that begins with the letter J. So it's a select something.
Select last name, first name, and
Yes.
cell phone.
Yes. Lazy here. From employee. Where experience level
is master.
Yep, and we can use that. And right.
Right, and
first name. Like we can do it this way. Yeah.
Yeah, like, and then J, and then the symbol thing. Yeah.
Yes. Like that. So that works. I think. Yeah. So what about if I do left? This works. Ah, that works too. Yeah.
Cool.
Yeah. All right. See, we did 4. We did 5. Okay, write an SQL statement to list the first name, the last name and first name of employees who worked on a property owned by a corporation. Use a subquery. Okay, so a property. Okay, so we want to write a select
star.
Yeah, but we only need the last name.
Oh, last name. Sorry, yes. So that's like last.
From employee, and that's going to be where it's going to be something that comes out of
the property service table.
Yeah, right. Employee ID, right? Employee ID is in something. And the something is a set of properties. Select some employee IDs from, is that property service, right?
Yes.
Where property ID, it's property ID, right?
Yes.
Is in something, I guess. And it would be in select property ID.
Property ID from the
property.
Was it owned prop?
Oh, yeah, owned. Oh, okay. A property ID from owned property. Yes. Okay. Yeah. Owned property. Okay. Oh, okay. From owned property. Where what property ID equals?
Let's see.
Property where owned property.
Oh, and then we got to link it to owner ID.
Owner ID. Yeah.
Or owner ID in.
Owner ID in the set of, this is the set of properties that are corporate owned, corporation owned, right?
Right.
Okay. Where select
the owner ID.
Owner ID.
From owner.
WNER. Where
owner type is equal to corporation.
The capital like that is.
Yeah.
Okay. All right, let's just submit this and see what happens. Oh, good.
Hey.
All right, I want to see what my notes are. I did that without even looking at my notes. Where are my notes? This was number 6. Yeah, that's what I had. Interesting. Wow, gee. Wow, I can't believe I. All right. All right, what's next? Write an SQL statement to, oh, now we're doing joins. Oh, okay, well. I'm going to start with this. And I'm going to put that here. And by the way, I'm just going to submit this and see what happens. Dong. No join. So where, okay, it's the employee. I'm just going to do left. Oh, join. Oh, I wonder if natural join will work. Let's try natural join. Natural join property service, natural join owned property, natural join owner, where owner type equals corporation. Duplicates.
Ah,
All right, let's
distinct.
do some distinction here. Hey, all right. Okay, we got, yeah, how many, there's 10, right? Maybe I should. Let's see. Well, okay, let's just keep moving. Okay, this is write an SQL statement to last the sum, name the sum. Okay. Say, so doesn't say what I need. Select
Last name, first name.
And sum of hours worked for each employee. Sum of hours worked. That would be out of this table. Hours worked.
Ah.
What is that called again? Property
Service.
Oh, do I need to? No, that's not right. All right, I need to do some more than that. All right, I'm going to do this. Okay, the submitted answer comes up with that. Oh, I need to do something else. I need to group by employee.
Group by.
Can I just do this? Do I need to have the? I guess I can do that. Because I want this to be done for each employee. So I want the output to be in one employee per record, and so that's what this does. And then this sums all of the records that are grouped together. That sums them. All right.
Okay.
So that's question 8. Write an SQL statement to show the sum of hours worked for each experience level of employee. Name the sum total hours worked. Wonder how I can tell it's in descending order. All right. Show the results by experience level. Okay. select experience level, sum
of the
of hours worked, huh?
hours worked as total
from
employee.
yeah, just oh, but I got to get
Oh yeah, you gotta get the
property service thing in there. Well, I guess I can do employee first. Natural.
we'll join the property service.
Group by experience level.
Then order, let's see, by
Oh, experience level. Yeah.
oh sorry, yeah.
Experience level descending order. Oh, that's funny. Okay.
Oh, I think your order is spelled wrong. You're missing an E in the word order.
Yes.
Oh, sorry.
Yeah. Boy. Okay. All right. Okay. Well, I guess I can do the last one. Okay, so write an SQL statement to show the sum of hours worked for each type of owner, but excludes services of employees who have an experience level of junior. Okay. Select owner type. Sum of hours worked from as, oh, I don't say as what? I'm just going to leave and see what happens. I don't say what to call it. So I have to see if my grader works from I gotta do employee natural join up
Property service.
Natural join is it owned property, yeah, owned property, and then owner, I guess. Where experience is not equal to junior, group by owner type, no?
Yes.
Yeah, okay, I better fix that. I better fix it. This has to be there. And I don't tell you that. Okay. All right. Well, very good. I found a bug. Boy, this bug has been in there for three semesters. I guess people just figured it out. All right. Well, that takes us to the end of the class, and so next time I'll talk about the sections 5.5 and 5.6.
Okay, great.
And okay, all right.
Oh, I had a question about the forums.
Oh yeah.
How long would you like us to, like, how much would you like us to write? Do you want cited sources too?
No. It's not. Okay, so that's right. I was gonna say something about that. What I tell you a good way to handle the forums is I'm talking. Okay, so we're talking about the ones down here, right?
Yeah.
I would do something like uh, you know, plug plug these into a search a search box on Google and include the word database, and then
Okay.
just sort of see what comes up. And that does work better for this one. You can say machine learning tools, Python, Anaconda, TensorFlow, and then databases or something, and then just sort of see the connection. Really what he's trying to do is he just wants you to try to think about some of these topics that are hot today,
Okay.
but this is a database class, so sort of connect that. And so
Okay.
yeah, it's really 2, 3, 4 sentences is really all that. Yeah, it's not that big. It should be easy points.
Okay. Okay, great.
Right. Okay.
Okay, thanks. Take
Thank you.
care.
Yeah.
Thank you.
Bye.
Bye.